Hello everyone and welcome back to this channel. Today we are going to be looking at how to add an element to a binary heap. This is very important because the binary heap needs to maintain its property after the insertion. Okay, and this is why this video is very important. This is the 5th video, so you can check out the previous videos on this channel. So over here I have this set of instructions that I want to perform on this binary heap. Okay, these basically are insert operations that I want to perform on this binary heap. The first question to ask is, which kind of binary heap is this? We can have a min binary heap and we can have a max binary heap. So which kind of binary heap is this? And the best way to do that is to check the structure itself. So if you check out the structure, you discover that the value of the child node is always greater than the value of the parent node. So if you check over here, 6 is greater than 5, 8 is greater than 6, 13 is greater than 8. So you can see that the value of the child nodes are always greater than the value of the parent node. This makes this heap a min heap. Okay, so a min heap, the element at the root will be the smallest element in that binary heap. So now that we know which kind of binary heap this is, we can go ahead and execute these instructions. The first element that we are going to insert is 1 based on this set of instructions, and what we are going to do is to look for the insertion position. And because of the complete binary tree property of a binary heap, we have to insert from the leftmost part. Remember, we can't add this one to this side. We can't do this. Okay, we have to add it from the leftmost part, and that is this point over here. Okay, and but there is still an issue that we have to solve. So if you look at this binary heap, it is no more satisfying the binary heap property because 1 is less than 7. Okay, and this is a min heap, meaning that the value of the parent node should always be less than the value of the child node, and this is currently in violation of that. So what we are going to do is to bubble this one up. You can also call this shifting 1 up. Okay, so if I go ahead and do this, you can see now I have shifted 1 a step to the top. Then I can, so I mean, if you check this now, it is still not valid, right? Because 6 is still greater than 1. So we're going to shift 1 up again. Okay, so now we check the parent of 1. This is still not valid. Okay, 1 is still less than 5. Then we have to shift 1 up like this. Okay, so at this point we can see that 1 is less than its child nodes. Okay, and this is how we are going to insert 1 like in the binary heap. Okay, so this is good. Now the next element that we are going to insert is 13. Okay, so as usual, we are going to put 13 in the insertion position, and then we are going to check the parent. So now the parent of 13 is greater than 13, so that is invalid, right? So we have to shift 13 up by 1 step. Okay, then now we are going to as you can see, we only had to do 1 shifting up here. That is because 12 is less than 13, so this is valid, so we can leave it like this. Okay, then now we are going to insert 4. Okay, so we have 4 at the insertion position over here. Okay, but as you can see, the value of the parent node to 4 is greater than 4, right? So 4 has to be shifted up. Okay, then now we check the parent of 4 again, and it is still greater than 4, so we have to shift 4 up. Okay, then we check the parent of 4 to check if it is greater than 4, but no, so 1 is less than 4, right? And this makes this binary heap valid. Okay, so this is valid. So now we are going to insert a 0. Okay, so I mean the first thing that will come to your mind is a 0 is the smallest element in this binary heap, right? So we expect to see a 0 here at the end of the day, and that is exactly what we are going to do. So we're going to keep bubbling a 0 up like this. Okay, so now we have a 0 at the top. I'm going to show you the code of how this can be implemented at the last video on binary heap. Okay, so you don't have to bother about how we are going to write the code to implement this. I'm going to be showing you how that can be done. So the last element that we want to insert is 10. Okay, so we are going to try to insert 10. So if you check this, you can see that 10 is at the insertion position, and if we check the parent of 10, it is less than 10. So that makes this valid. So in this case, we didn't have to shift 10 up because it satisfies the binary heap property. Okay, and that is the last element that we want to insert. Okay, so this is how you can perform insertion in a binary heap. Alright, that will be all for now. Please don't forget to subscribe to this channel to stay in tune for the next videos, and I will see you in the next video. Bye.